Alright, hello everyone. So we are going to learn the final step of integration by parts. That means how to choose u. Okay, so I am going to teach you a one little trick to choose u. But the thing is that you cannot use that trick for every integration by parts problem. It is good for most of the problems, but it doesn't work for some integration by parts problem. I will teach them later in one of the next videos, but let's try to learn this little trick because it can help you to survive through most of the problems. So the rule help you to choose u, right? So it will help you to select u. Now once you know u, dv is everything else in the integral, right? Okay, so how do you choose u? We use the LIATE rule. Now what does that mean? Well, L in the LITE means L means logarithmic functions like natural log x, natural log 2x, logarithmic functions. Now inverse functions means sine inverse x, tangent inverse x, something like inverse trigonometric functions. Algebraic functions are like x or polynomials, x square plus 1 square roots, okay, those type of things. Trigonometric functions are sine x, cosine x. Now don't mix up them with inverse trigonometric functions. That's a different category. These are just simple trigonometric functions, sine, cosine, tangent, okay. E means exponential. That means ex, e to the 2x, those type of functions. Now, what is it to do with choosing u? Well, the priority goes down when you move below in the list, when you go down the list. That means your choice for u, logarithmic functions will be your first choice. If not, then inverse. If not, then algebraic. If you don't have algebraic, then trigonometric. The last choice for you will be exponential functions. Okay, so that means you will have two type of functions in your integral in most of the cases. Out of those two type, decide what type of functions that you have, decide which one is on the top of the list, and that is your u. Pretty easy, right? So let's do an example. X times natural log x. What type of functions you have? We have an algebraic, we have a logarithmic. L is on the top of the list, so u is natural log x because natural log x gets the priority. Alright, so let's solve the full problem. So u is natural log x, then what is dv? Everything else except u, right, which is x. Don't forget the dx, that is the definition of differential. Okay, now we use the formula which is uv minus v du. Now u natural log x dv x dx, so to get v out of dv we integrate x, we get x square over 2. Don't differentiate there. To get du we differentiate u, du over dx, derivative of natural log x is 1 over x, du is 1 over x dx, right? So we have every tool that we need for the integration by parts formula. Now let's use it. So u is natural log x, v is x square over 2 minus v is x square over 2, du is 1 over x dx. Now the next thing is you check here whether you can simplify your integral or not. Here we can cancel out a 1x, so x square over 2 natural log x. Here if you cancel out a 1x we get x square over 2 here. Now if you integrate x you get x square over 2, right? You get a new 2 on the bottom. That new 2 and this 2 will give you 4. 2 times 2, 4 plus arbitrary constant c. Don't forget that also. So this is the answer, right? Okay, let's solve more problems. Let's see how to choose u in more problems. So I did something like question 1, but here u is natural log x because this is a logarithmic function. This is algebraic function. Here we have an interesting example. So we have x minus 2 sine 2x. Now what is the choice for u? Well, we have an algebraic function and a trigonometric function. A comes first, a comes before t, so u is x minus 2. Alright, so then dv is everything else, sine 2x dx. Don't forget dx. So if u is x minus 2, du over dx is derivative of x minus 2 is 1. So du is actually dx. Okay, don't forget the dx. v is sine 2x, so if you integrate sine 2x, you get negative cosine 2x over 2. Okay, do the integration correctly. So we know u du dv v. Let's use the formula. So the formula is uv minus v du. Okay, so u is x minus 2, v is negative cosine 2x over 2, so that is this part, minus v is negative cosine 2x over 2, du is dx. Alright, so here can we simplify? Well, here negative negative plus, so minus x minus 2 cosine 2x over 2, here plus integral of cosine 2x over 2. Alright, so let's integrate cosine 2x. Here we get x minus 2 cosine 2x over 2, nothing changed there. If you integrate cosine, you get sine 2x and you divide by another 2, right? Because if you integrate cosine 2x, it will be sine 2x over 2. That new 2 and this 2 will multiply and we'll get 4 here plus c, right? So this is the answer that you get after integration. Okay, alright, so let's see whether we have a different type of example. Well, we have x times e to the negative 3x. Let's do that and finish the video. So x e to the negative 3x dx. Okay, here the choice of u is, here we have algebraic function and exponential function. So algebraic is top of e, so u is x. dv is e to the negative 3x, don't forget dx. Now if you differentiate u, we get du over dx, derivative of x is 1. So dx is, du is dx, right? Okay, now if you integrate dv, if you integrate e to the negative 3x, it's e to the negative 3x over negative 3. Do that carefully. Now the formula is uv minus v du. U is x, v is e to the negative 3x over negative 3 minus v is e to the negative 3x over negative 3, du is dx. Alright, so here negative negative plus, we can simplify that, so x e to the negative 3x over negative 3 here, plus you have to integrate e to the negative 3x over 3. Alright, so if you integrate e to the negative 3x, here you get minus e to the negative 3x, divide by minus 3, that is why I had minus here. So if you divide by another 3, that 3 and this 3 will multiply, not add. 3 times 3, 9 plus c, right? Okay, so this is the answer. Alright, so now we know how to use the integration by parts formula correctly, and we have a nice little trick to identify u. Now what are we going to do in next videos? Well, we are going to learn the cases that we cannot really use that nice little trick and some advanced level integration by parts problems. Okay, alright, so I will see you in the next few videos. Thank you very much. Bye bye.